This is Europe. By 2050 it will become one interconnected urban region, like many other parts of our planet. More and more surface area will be required to feed this massive city. But do we have enough agricultural area available to allow the system to survive? Or should we look for alternatives? Should we maybe introduce the farm to the city? In the 40 years of activity, Quick has shown to be entangled with the development of the city. They managed to feed the urban dweller at an affordable price. What if Quick could become a solution for urban feeding? What if Quick could become a solid provider of the urban need? What if Quick could become mobile, be there where the action is? Contemporary city dwellers are never static, they just sort of flock around. That's where we have to be where the people are. Quick will become a full provider, providing the urban dweller through urban farming, and being there where the dweller flocks. Let's take Brussels as a case study. How can we find an optimal spread for the different urban farms, thus generating several communities of the tower? Now let's zoom in at one of them. In this particular area, we will need to grow a tower that is both light and airy, thus generating an urban reef that provides the required growing surface. Genetic algorithms provide an adequate methodology to grow urban farming towers. Cellular automata are an algorithm first introduced by the mathematician John Conway. In an analytical way, it generates a matrix of points, in which every neighbor is considered to one another, thus generating the required reef-like tower as a set of superimposed control points, which form, if connected, a complex of connected growing towers. That's the static side of the story. Now let's look at the dynamic flocking swarming side of the urban dweller. How can a static restaurant become a dynamic unit? This requires strict analysis of the flow patterns and necessity zones of food demand during every period of the day. A flow pattern emerges that can be implemented into the movement scheme of the mobile units that are fed from the central towers. The movement of these mobile units is fully automatic and follows the logic of birds in a flock. Boids are an algorithmic method to describe this behavior. Every particle can become a mobile unit, and their behavior can be set up according to predator-prey relationships, thus achieving a flock that searches a goal without losing the movement behavior of each individual boid, in which it positions itself toward the movement of other boids. If we translate this behavior to our location, the Boyd's movement set up with a predator-prey relationship will show a concrete implementation of the experimental model.